Well, here are the answers to exam number 2. There are 6 questions here, and we'll start with the first one. This is the case of a car taking a curve, but the banking is itself not enough to keep the car on the road. So here are the forces that act. Number 1, we have the weight of the car acting vertically down. Then we have the normal force acting perpendicular to the road. The normal force is resolved into its 2 components. That's the vertical component, and the blue arrow is the horizontal component. Friction acts tangential to the road, and the red arrows show its components. From the geometry of the diagram, this is going to be Fn cosine theta, and this would be Fn sine theta. Again, resolving friction into 2 components, you get F sine theta as the vertical component and F cosine theta as the horizontal component. So that is basically how the diagram looks. And now we need to see what the net forces are along the x-axis and the y-axis. Now, the net force along the y-axis is Fn cosine theta minus F sine theta minus mg is equal to 0. So those are the 3 forces. And then Fn cosine theta is equal to the other 2 taken to the right side become positive. The idea here is to make Fn the subject. But before that, remember that friction is mu times Fn. So that substitution is made here. So friction is mu times Fn. And then finally, you bring this term also to the left-hand side, so it becomes negative. And then take Fn as a common factor. So that leaves cosine theta minus mu sine theta, which is equal to mg. So that's one equation. And we can, of course, make Fn the subject, and that will give us mg divided by cosine theta minus mu sine theta. So let's call that equation number 1. Now, considering the forces along the x-axis, we only have 2 forces. One is F cosine theta, the other is Fn sine theta, and both are acting towards the center of the curve. Remember, this road is curving this way. And so these 2 together provide the centripetal force, which is mv squared by r. Once again, we manipulate that equation to make Fn the subject. Friction is again mu times Fn, and Fn is taken as a common factor. And then make Fn the subject, which will give mv squared by r divided by the whole of sine theta plus mu cos theta. So that's the second equation. Now you see that the left-hand sides of both the equations are equal. Therefore, we should be able to put the right-hand sides equal to each other. So that's equation 1, that's equation 2. Let's put the right-hand sides of both the equations equal to each other. So So that gives mg by cosine theta minus mu sine theta is equal to this whole thing. And the next step is to cross multiply. Which means you multiply this term with all of this and this term with all of this. So I've done all of those steps and I'm trying to save time here. So when you cross multiply, you get this. And then the idea is, of course, to separate mu. And you see that mu exists in two terms. That's one and the second. So we got to bring both of those terms to one side and then take mu outside. And then make mu the subject. Now in the last step, I've divided each term by cosine theta. So the cosine thetas here will get cancelled, but when divided by cosine theta, this will become tan theta. So that's the final equation that we get, into which we could substitute the values and find the answer. In this question, the force on a 0.5 kilogram particle is given as a function of x. So fx is x squared plus 6x. And it moves from x is equal to 0 to 4. We're asked to find the speed. Now remember that work is integral x is equal to 0 to 4 fx dx. And now substitute for fx, which is x squared plus 6x, and then integrate that expression, which will give x cubed by 3 plus 6x squared by 2. And then we have to substitute the limits. So when you substitute the limit x is equal to 4, so substitute 4 in place of this and calculate, we get 69.33 joules. According to the work kinetic energy theorem, the work done should be equal to change in kinetic energy. Therefore, now you put this equal to 1/2 times mass times velocity squared, rearrange, manipulate that equation, and calculate the velocity, which gives us square root of 277.32, which is 16.7 meter per second. So that is how that problem is worked out. The next question is regarding this Atwoods machine, where you have a heavier mass and a smaller mass connected by means of a string. How do you draw the free body diagram? Both of those masses have two forces acting. One is the tension in the string. The other is the weight. But for the bigger mass, the weight is going to be bigger than the tension. So when you take the net force, it's going to be mg minus ft is equal to ma. For the smaller mass, ft is greater than mg because it's moving up. Therefore, ft minus mg is m times a. Now, to solve the equations, actually, you can add the two. When you add, these two terms get cancelled because one is positive, the other is negative. And then separate g from one side and a from the other and make a the subject. So you get this equation into which you substitute the given numbers. We will be able to figure out the acceleration of the system. Now most of you did do this part, but very few could calculate the tension. And that is surprising, because once you get the acceleration, in this case it's 1.96 meter per second squared, all you got to do is take that and substitute into one of the equations. Let's say you substitute into this equation. So then you get, that is the equation, and then you take this to the other side, it becomes positive. Mass is common, so take that out, and so it will be mass multiplied by G plus A. Plug in the numbers and you get the tension in the string. Of course, the tension in the string on both sides are equal, and that is understood. And the tension can be calculated in that way, and here in this case we get 4.7 newtons. The next question is regarding a projectile that is fired from ground, and we have to find the speed of the projectile when it has reached a height equal to half of its maximum height. Very important thing is to remember that at the highest point, the projectile only has the horizontal velocity, which is V naught cosine theta. We get it as 22.98 meter per second, because the vertical velocity here is 0. Now, applying the principle of conservation of energy, we know that the potential energy here is 0 because the height is 0. So its kinetic energy is given by 1/2 times mass times velocity squared. We do not know the mass, so we get 450 times m. And at point B, it has both potential and kinetic energies. And that's mgh. So mgh, we do not know the height, plus 1/2 times m times the velocity squared, okay, at the highest point. So that gives us that equation, again in terms of m. And we know that the total energy at A is exactly the total energy at B. So we can put these two equations equal to each other. And when we do that, the masses will get cancelled, and we'll be able to calculate the maximum height. Get the height as 18.97 meter. Now we are asked to find the speed at half of the height. Once again, we'll apply the same thing. So if c is where it reaches half the maximum height, we know that the height is half of this number, which is 9.49 meter. And again, the total energy at A is equal to the total energy at C. So we put this equal to, at C, you have mg times h plus 1/2 times velocity squared. We do not know the velocity, which is what we're trying to find. So the idea is that the total energy at C is equal to the total energy at A. So the masses again get cancelled, and when you do the calculations, you get the velocity as 26.7 meter per second. I know some of you did do this using kinematics, but you can see that this is a much easier method of working out this problem. The next one again is a very important question where you have a 50 kilogram block being pulled up at a 17-degree slope. Here are the forces. One is the applied force used to pull it up. The other is friction, opposite to the motion. This is the weight of the object, and this is the normal force. So those are the important forces. And now, since this is the x and the y axis, we are resolving the weight into its two components, mg cosine theta here and mg sine theta along the horizontal. Once we do that, we got all our forces either along the x or the y. And then we can find the net force along the y. We have Fn minus mg cosine theta is equal to 0. which gives us Fn is equal to mg cosine theta, using which we can calculate the friction, because friction is mu times Fn. So that is mu times mg cosine theta. And then now we take the net force along the x-axis. We have Fa minus both of these, which is minus friction minus mg sine theta, should be equal to, by Newton's second law, mass times acceleration along the x. So once again, friction is mu times Fn, but we got friction as mu mg cosine theta. So I've substituted that for friction. Get that equation. Remember, we're trying to find the acceleration of the block, so make that the subject. And we have all the quantities required to calculate the acceleration now. The applied force is 250. The coefficient of friction is 0.2. Mass of the block is 50 times 9.8 times cosine 17 minus mg sine theta again. Divided by 50 kilograms, which is the mass. And when we do those calculations carefully, we will get the acceleration to be 0.26 meter per second squared. And this last question is about the International Space Station. You're asked to find its time period and the speed. Now remember that it is the gravitational force that provides the centripetal force. So the gravitational force is gme times m by distance squared, which is the sum of the radius of the Earth and the height above. Well, this is not drawn to scale because the height is much smaller than the radius of the Earth. Anyways, the masses get cancelled. You rearrange. You get this as the velocity. And that's the universal gravitational constant. That's the mass of the Earth. And when you take the radius and the height together, remember the height is given as 370 kilometers. And so that has to be in meters too. Once you do that, you get .370 times 10 to the 6. So I've taken 10 to the 6 to be common. And so that gives 7.685 kilometer per second. Now to find the time period, it is the time taken to go around once. And so time is displacement by velocity. And displacement is the circumference of the circular path, which is 2 pi r. And the velocity is what we got just now, of course, in meter per second. So when you do that, 2 pi times this distance as before, you get 5,518 seconds, which is about 1.53 hours. And so that is how we calculate the speed and the time period of the International Space Station. Thank you, and I hope you understand this, and I hope this is useful for you, especially for the final exam.